All right, IBSL1. Today we're going to almost get through 3.2. It's kind of a long section of linear equations, but we're going to talk more about linear equations, lines. The first two equations I want to talk about are kind of some special cases of horizontal lines and vertical lines. I feel like I always run into students that forget how to represent these with an equation. So I have two examples for you guys. One is a horizontal line that goes through y equals 4. I mean, I kind of gave it away right there. That's the equation of the line, y equals 4, because all of them have a y value of 4. No matter what x value you put into them, you get a y value of 4. So this is y is equal to 4. Now, if you were to take two of these points and plug them into the slope formula, you would get y2 minus y1 over x2 minus x1, so we get 0 over 3, which is just 0. So horizontal lines have a slope of 0. Now this vertical line here, notice that all of these have a similar x value of 3. So the way you represent this with an equation is you just say that x is equal to 3. If you try to find slope of, like, say, these two coordinates right here, and you do y2 minus y1 over x2 minus x1, and then you get negative 4 over 0, you guys, you can never, ever divide by 0. So this is a problem. This means that this is undefined. So vertical lines have no slope. So the way I remember that is that if you picture yourself as a little person walking on these graphs that, like, right here, you can walk on this horizontal line, which means that's a slope of 0. The slope exists, it's just 0. But then if you picture yourself trying to walk on this line, you guys, we're falling through the air so fast, down into fire. That means that there's no slope there because you can't walk on the vertical line. So slope of 0 with the horizontal, no slopes with the verticals. We, last class, definitely talked about this form where this is your gradient and this is your y-intercept. But what we didn't talk about is point gradient form. I feel like there's a hyphen there. Point gradient form means that this is still your gradient. But now y1 and x1 are just any point that's on the line. So we'll say that x1, y1 are a point on the line. In general, I think that we can just use gradient intercept form. I don't see the point, no pun intended, to point gradient form. Sometimes I'm like, why is it useful? I feel like we always just put it in gradient intercept form, slope intercept form. Find the equation of each line. The first one, it goes through negative 4, 5 and is parallel to that. So that word parallel to, from last lesson, we know that it has the same slope. So the slope or the gradient is negative 1/2. So really, the equation is like y equals negative 1/2 x plus c, but we don't know what the c value is. That's where we have to take this point and plug in the x right here and the y right here. So we get 5 is equal to negative 1/2 times negative 4 plus c. Now we have to get the c by itself. Negative 1/2 times negative 4, negative times a negative is a positive, 1/2 of 4 is 2, so we get 2 plus c, subtract 2, we get c is equal to 3. So we get y equals negative 1/2 x plus 3. Okay. The next one says that it goes through negative 1, 2 and 3, negative 4. This is similar to the last one, except we don't know what the slope is. So first, we're going to start with the slope equation, which is y2 minus y1 over x2 minus x1. So on top, we get negative 6. On the bottom, 3 minus negative 1 is 3 plus 1, which is 4. So we get reduced fraction, negative 3/2. Which means that the equation is y equals negative 3/2 x plus c, but we don't know the c value. Here's where you can take either point, either the negative 1, 2 or the 3, negative 4, and then plug them in for the x and the y right here. I'm going to choose the negative 1, 2 because smaller numbers, I guess. So the y gets replaced with 2, and then the x gets replaced with negative 1. Oh, we're going to have to do a common denominator. Negative times a negative is a positive, so we get 2 equals 3/2 plus c. So then we get 2 minus 3/2 is equal to c. But then we need a common denominator, so we'll continue up here and say this is 4/2 minus 3/2 is equal to c. So 4 take away 3 is 1, so this is 1/2 is equal to c. So we get y is equal to negative 3/2 x plus 1/2. Example, sketch a graph of the line y plus 4 equals negative 2 times x minus 3. Okay, there's two ways we can go about this. One way is to change this equation and get it into gradient intercept form, like a y equals mx plus c. The other way is that this is basically in point gradient form. That the gradient, this is the slope, the gradient, and the point is 4, 3. So it goes through 4, negative 3. Make sure that's right. Yeah. So you could start that way and say, like, put the point 4, negative 3 on it on the graph and then use the slope. Or I'm a fan of just kind of like rearranging this, like distributing. I'll leave the y plus 4 alone, and then I'll distribute the negative 2, so you get negative 2x plus 6, and then subtracting 4 from both sides, so you get negative 2x, and then minus 4, that's plus 2. So then I think it's easy to see your y-intercept, and your slope is going down 2 over 1. So let's plot that y-intercept at positive 2, and then go down 2 over 1, down 2 over 1, because the slope is negative 2 over 1. And then down 2 over 1 again. Let's see if I can connect them with a proper line. Nope, I'm off. Something like that. Yep, that's it. All right, next problem. There's a third form of lines called general form, where you get ax plus by plus d is equal to 0, where a, b, and d are all whole integers. Whole integers means no decimals, no fractions. It's okay to have negatives, positives, obviously, but yeah, whole numbers. So first example, we're going to put this into general form. Well, the first thing I don't like about this is the fraction. So what I'm going to do is take both sides and multiply them by 4. Because then that will get rid of this denominator of 4. So we get 4y is equal to negative 3x plus 8. So the 4 got distributed to here and to here. Then we need to get everything on one side and set it equal to 0 with the x first. So if I scoot the x over to the other side, you get 3x plus 4y minus 8 is equal to 0. And then we are done. Yep. Okay, next up, draw the graph of this. You guys, general form is kind of lame. It doesn't really help you with anything. It's not like you can spot the slope or the y-intercept or even a point it goes through. So what we're gonna have to do is put this back into gradient intercept form, aka get the y by itself. So I'll start by subtracting 3x from both sides. So we get 4y minus 8 is equal to negative 3x. Then I want to get the y by itself, so we'll add 8 to both sides and get 4y is equal to negative 3, that's an x, plus 8. Then to get y by itself, you divide by 4, so you get y is equal to negative 3/4 x plus 2. Now I can see the slope and the y-intercept. We start at 2, go down 3 over 4, so down 3 over 1, 2, 3, 4, down 1, 2, 3 over 1, 2, 3, 4. Play connect the dots. It looks something like this. Yep, that's it. Okay, so for this part, I'm going to talk about a couple different ways you can solve this. First of all, the problem is use your GDC, your graphics display calculator, to find the point of intersection for those two lines. Now, if I took away your calculator, we could graph both of those and make a guess as to where they cross. If they cross at a nice point, this problem's not too bad. Where you might have to use your graphing calculator is if they cross at a very uncomfortable point, like they cross at 1.89, 2.63 or something like that. So in general, you're going to want to graph both of these on your calculator. So we're going to graph this in y1, graph this one in y2, and then I'm going to post another video for you guys explaining how you find the intersection between two things, or we'll just do it live in class with calculators. We'll do a couple of these. If I were to sketch these, let's see. The first equation starts at +1 and then goes down 3 over 1. 1, 2, 3, down 3 over 1, down 3 over 1. It looks something like this. The second equation, which I will do in orange here, starts at +1, 2, 3, and then goes down 5 over 1. So down 1, 2, 3, 4, 5 over 1, down 1, 2, 3, 4, 5 over 1. So if I connect these, it looks like this. Now, you can see that these two do cross at a point right here. That point being +1, -2. Now, if that's truly an answer, that should work in both the original equations. So if you want to check your answers, you should plug it in to both of them. So the first one, we get -2 equals -3 plus 1. So you get -2 equals -2. And then you go, yay, it worked. But you should also do that in the second one. You should say -2 equals -5 times 1 plus 3. So this is -2 equals -5. Plus 3, so you get -2 is equal to -2, and you say, yay, it worked as well. Now, this was a very baby example of finding the intersection of 2 points. Once again, if we're going to use our GDC, we're probably going to make it an intersection that's not nice, like one that doesn't work out well. You can do it algebraically, but I don't think we're covering that today. Last problem. If you're going to solve this by using your GDC, you're going to take this side and set it equal to y1. And then take this side and set it equal to y2. So we get y2 is equal to -1.37x plus 26.5. And then you're going to graph both of them and see where they intersect. I think when you set up your graph that it looks something like, and we'll confirm this with calculators in class, it looks something like this for the first line and something like this for the second line. So I'm going to show you guys how to find this intersection using a graphing calculator. And then you guys should be good to go. So this is also the cheater method of doing algebra. Like, we could solve that by, just getting x by itself, but it's good that they're teaching you the cheater method on a calculator, so you guys can be cheaters. Yeah, cool. All right, guys, that's all I got. Let's work on some calculator skills and dig into that homework.